Okay, so the object of this video, or this next couple of videos, is going to be to understand how a program is compiled, assembled, machine code, into our microprocessor. Okay, so the easiest way to understand this is, let's just draw a little diagram here. It's not even a complicated diagram. So we have our programming language, and for this course we're just using C. And so we write our program in C to do our task. Then this gets translated into something that's called assembly language. And this is part of what the compiler does. But then that assembly language gets transferred into something that's called machine code. And this is also done by the compiler. Now, for those of you who have taken courses in compilers or know a little bit more, you know that they're a little bit more involved, in the sense that you've got your compilers, you've got your linkers, and all the things like that. And I understand that, but for the purpose of this course, we're just going to kind of look at that and call all of that just compiling. But it goes in kind of three major things. We have our programming language, which we write the code that for the task we want to accomplish, and then we have the assembly language, and then we have the machine code. So this is actually a very good diagram. I'm going to modify this slightly from your book here, as far as what the program is doing. But basically we're going to look at page 17, and this has got a very simple C program here. We're going to write the code here. So I have int a equals 1, int b equals 2, int c equals 0, and then what we're going to only do here, we'll have our main program here. So these are global variables I declared, and then we'll have our main program, int main. It's a void function, and then this is my code. All I'm going to do is say C is equal to A plus B. We're actually going to eventually program this particular thing here, or something similar to this, so we can see how exactly this ends up getting worked in, worked in the assembly program. So the first thing here, if we're talking about assembly here, is we would have, let me put it in a different color here. We would have, in assembly, we'd have A DCD 1, DCD 2, C DCD 3, and then there's some other stuff in order for the main program. You know, there's some other parts of the assembly language that you need to put in there, but we're not going to actually worry about this. All I'm going to do here is say, okay, I'm going to do an LDR R1 equals comma A LDR R3, and I know it's a little bit different than what the program has on page 17, but it's, for our example, it's going to work better this way. Equals B, and then we're going to have a command here, adds, and we're going to say R5 actually, I'm sorry, I messed this up a little bit. We do need to do what the program has here. What we're going to do here now is do LDR R2 bracket R1. Then we're going to do LDR R3 equals B, LDR R4 R3, and then we're going to do adds R5 R2 R4, and then we're going to do LDR R6 equals C, and then STR R5 R6, and then basically that's the end here. Now I want to emphasize here, notice that, you know, this is a very simple program in programming language. You know, A equals 1, B equals 2, C equals 0, and then we do C equals A plus B, which we know then of course C would be 3. But now when we look at the assembly language of this, it's actually quite a bit more complicated on the steps we need to do. Because the first thing we need to remember here is any kind of arithmetic operation, we need to load that data into the registers. Because the registers are what provide us the ability to add, subtract, and do all sorts of other things quickly. Okay, now first let's kind of dive our way through this here. So here, these first things are declaring basically a variable A and storing 1 in that location. And actually this shouldn't be 3 here, I just realized I was putting what the answer should be. That should be 0. B we're declaring to be value of 2. C we're declaring DCD to be a value of 0. Now when we execute this line here, this A DCD 1, basically two things occur here. What happens is we first, and I'm going to erase this here in a second, we first get a memory location for A. So it's building us a memory location for A. And basically what it's doing is it's assigning us a memory location. So for instance, it might assign us it might assign 0x0000 1 F A, let's just say. It might say, okay, that's where I'm going to store the data for this variable A that you've declared. And then what it's going to do, the second thing is it's going to then store the value 1. And actually, if you want to be technical, what it's doing is it's storing 0x01 in the memory location. Okay, so that's what that command is doing here. So I'm going to actually erase that right now. As I said, I'm not going to need that, so I'm going to go ahead and erase that. But then this DCD2, BDCD2 is going to do the same thing. That's going to be declaring the value variable 2 and declaring the variable b and storing the value 2 in it. Alright, now let's go down here to the main set of code here. Basically right here what we have is LDR. This stands for load register. And well, how do I know how to do this? Well, of course I just copied it from the book, but basically you can take a course in just assembly language, and there's just like a programming language, there's just rules for how to do things here in assembly. So LDR means I'm going to load a register, and then you first what register are you going to load, and what is the data you're going to put there. So this command here says we're going to load into register 1 and then this is what we're going to load in here, but this is what's a little confusing, and I made my mistake here. Equals A, that's not putting in the value of A. What this is storing in the register, this is storing the memory address for A. So that's what's being stored there, is it's actually giving me the memory address as opposed to the actual data. Okay, well then this second line you can say, okay, well what is this doing? This is going to load into register 2 and then these brackets here, R1, is going to be the data stored in memory location. That's what the brackets are, is basically saying, hey, this is a memory location, R1. So I first loaded the memory location into register 1 of where the data is located. Then I stored the actual data that I'm wanting to add in register 2. Now I've got to go through the same thing here again. I've got to first store the memory address for the variable b, and then I have to grab that data for variable b. So I have to grab that and get, okay, R4, grab that variable data, which is stored in the memory location R3. Alright, now this line you can probably guess, adds is going to be restoring, it's adding the data. But the way this works, and this is a general rule for the way any of these commands work, is adds, the first thing we're going to do is it's going to store result in register 5. And add data from R2 and R4. And then we store, or I'm sorry, load in the memory address for variable C. but we're not loading that data in. What we're wanting to do here, if we look at the code here, is C is supposed to contain the result of A and B. Well, the result of A plus B was stored in register 5, and so I'm going to store in register 5 the value of register 6. Now remember, I'm not saying register 6, because if I just did R6, that would be the address of R6, where the address of R6 is. And I want it to be the data inside R6, so that's why I put the brackets around there. Now, the good news is we're not going to be really writing a lot of assembly language at all in this course, although I think it's kind of fun to do, but it's reserved for a different course, a different CPE course where you do more assembly language stuff. But that's kind of the gist of what's going on. So basically, the first step here, when we're building a program, now this is all done in the background for us. The first step is that we write our code. Then the compiler produces this assembly language here. So the compiler produces this. But then this is not what we actually program into the machine. Because basically what it is that there is memory addresses, and not memory addresses, I'm sorry. There's actually command codes that you have to use to actually get everything properly stored in here. So let's go ahead and write some of these down. I'm not going to write all of the machine code down here, but I'll write some of it down. And I'm going to go to the LDRs here. So I'm going to pause the video for just 1 second. Okay. So I was going to tell you here some machine code here, and I'm going to do a little bit, but as I said, it's kind of complicated to get to this here. So if we look at here is this LDR R1 comma equals A. Here, let me do a different color. The actual machine code for this is 0x4903. So this here contains all this is it looks kind of weird, but this is what would be stored in the microprocessor in order to do this command. And then for the next line here, it would actually be 0x680A. That would be for this next line. Now you might say, where am I getting all of this stuff here? Like, how do I get this? Well, of course, right now what I'm doing is just copying it from the textbook here. But I will get you here how we can do this here, on the way this works here, just real quickly. Give me 1 second to pull something up here. So the way this works here, to get these kinds of numbers here, is it's actually not an easy task to do. There's a whole chapter on how to encode things here. Let's, for instance, say we wanted to do add and like an add instruction. So let's just say we wanted to do this add here, where we do RD RN and RM. So RD is destination, N and M are what we're adding. Similar to the adds instruction, but in this case we're doing add here. So if we look at this, there is 16 bytes just to get this to work correctly. Okay, so this is the 15 and 16 here, and all of these have to be set here. So the first, we don't have choices in some of these. For instance, we have that R15 has to be, this has to be 15, that's going to be 00011. and then it's 0, 0, RM, RN, RD. So as an example here, if we wanted to encode something here, let's for instance say that we were doing an ads, not an ads, an ad, let's say R5, R4, and R3. Now for simplicity's sake, we're just going to say that these are just these registers, their memory addresses are just whatever the subscripts are here. So this would be 0, 1, 1, this would be 1, 0, 0, and this would be 1, 0, 1 for the different registers. Okay, so then the machine code for this here is what's called, sometimes this is your op code, meaning this code here is what tells the control unit that this is the particular type of add command we're going to do. So this up in front here we don't get to change because this is what's called my operation code. It tells the control unit precisely what we're going to do here. And then this is the data that it needs in order to execute that properly, because it needs to know, well, where's the destination register and what two registers am I adding together. Okay, so if we did this here, we'd have, again, these don't change, 0, 0, 1, 1, 0, 0, and then this would be we have to be careful, RM would be 0, 1, 1, because we have to follow it in order. RM is the last one here. RN would be then 1, 0, 0, and then RD would be 1, 0, 1. So then this string of bits here is what we'd actually program into the microprocessor in order to do this command of adding those three registers together. Now, what we normally do is we don't look at binary like this. What we do is we look at this in hexadecimal format. And so what we would do here, most likely here, is go ahead and group these in 4s. Because if you group them in 4s, you can easily convert it to hexadecimal. Oops. So if I look here, this would be 1, and then 1, 0, 0, 0, so that's 8, and then 1, 1, 1, 0, that would be 14, which is E, and then 0, 1, 0, 1 would be 5. So this is what would be stored in memory in order to execute that one line of assembly language. So that's where these weird numbers 4903 come up with and 6808, is because we're doing LDRs. You might say, well, why are they so different? Well, because they're different formats. In this second case, we're doing a load of data given a memory address, and in this case we're doing a load into the register of a memory address itself, and so those LDR commands are actually different as far as the opcodes for them. Even though it's still a load command, the opcodes are different. If you look on page 617 in your text, you can see there's different opcodes depending on the type of LDR that you are performing, which is why the syntax is important. So you can see here, if you were trying to go through this by hand to do this, because back in the day before we got sophisticated, people would actually, you'd have people sitting there punching these numbers in, programming a microprocessor where you'd punch in 4903, because I'm going to be storing that in this memory location, and then I'd punch in 6808 because I'm storing it in that memory location, so on and so on. Now this is all just done for us. So again, what happens here is we write our code, it gets compiled to assembly, that then further gets taken down to machine language. This machine language, then, this is what goes to chip. Now, the good news for us is this is about as much of kind of the overview I want to do as far as how the microprocessor works. The good news for us is we're just going to be focusing in this course on writing the code. So the next couple of lessons are going to be just reviewing C, and then remember we're going to have an exam. Now some of this will be on the exam in the sense that I expect you to be able to draw either the von Neumann architecture or the Harvard architecture. Even though I didn't draw the Harvard one here, it's in the textbook on page 5. So that could be an exam question where I have you draw it and explain how this works, like we did here in the video. You'll have to know what are the purpose of registers, how many registers do we have. You'll need to know the 3 special purpose registers, and then you'll need to understand this programming language to assembly language to machine code. You will not actually have to create any of the machine code like we did in this example here, but you should definitely be able to explain going from programming to assembly to machine, explain the differences there. And then we'll also have some stuff just with C programming that will be there as well.